Good day everyone. In this video, I will discuss the proof in finding the days of the week using Gregorian calendar. But before that, let us define first what is Gregorian calendar. A Gregorian calendar is the most widely used calendar system today, particularly in the Western countries. It was introduced by Pope Gregory XIII in 1582 as a modification of the Julian calendar to align more accurately with the season. It was designed to improve the Julian calendar, which had become slightly out of sync with the season. It changed the way leap years were calculated to create a more accurate average year length. So the formula in finding the day of the week using Gregorian calendar is the day of the week is equal to YC plus MC plus CC plus DN minus LYC modulo 7, where YC is the year code, MC is the month code, CC is the century code, DN is the day number, and the LYC is the leap year code. For the year code, to calculate it, we have the formula year code is equal to YY plus YY over 4, where YY is the last two digits of the given year, and after that, we can substitute it to the formula and we will now get the year code. So for example, the year is 1897, so the last two digits that we will get is 97 and substitute it to the formula. We will have 97 plus 97 over 4. First thing to do is we divide 97 by 4. We will only get the whole number. So 97 over 4 is 24, and 97 plus 24 is equal to 121. So the purpose of dividing by 4 is first is for leap year identification. A leap year occurs every 4 years. By dividing the last two digits by 4, we can find out how many leap years occur from the start of the century up to that year. So next is adjusting for extra days. Each leap year adds an extra day, which is for February 29 to the calendar. This division helps account for these additional days when calculating the total number of days in the years leading to that given year. Next is the month code. So to compute the month code, we need to memorize the numbers 0336, 1462, 5035. So the corresponding month codes for each month are as follows. For January, we have 0, February is 3, March 3, April is 6, May is 1, June is 4, July is 6, August is 2, September is 5, 0 for October, 3 for November, and 5 for December. For example, if we have Dina's birthday is in February, so the corresponding code for Dina's birthday is 3. Next is the century codes. So from the Gregorian calendar, the numbers 4206 are alternatively taken. So the corresponding century codes are for 1700s we have 4, 1800s is 2, 1900s is 0, 2000s is 6, 2100s is 4, 2200s is 2, 2300s is 0, 2400s is 6. So for example is the year is 2020. So the year 2020 is included in the century 2000s and it has the corresponding code, which is 6. Next is the day number. So the day number is simply the day of the given date. For the leap year code, if a Gregorian year can be divided by 4, it is a leap year unless it is divisible by 100. But it is also a leap year if it can be divided by 400. So for example is 2020. 2020 is a leap year because it is divisible by 4. while 1700s is not a leap year because it is divisible by 100, and 2000 is a leap year because it can be divided by 400. If the date is in January or February of the leap year, the total sum will have to be subtracted 1 before the final step. So the formula is day of the week is equal to the year code plus month code plus century code plus day number minus 1 modulo 7. So for example is January 1, 2020. From the date, 2000 is a leap year because it can be divided by 4. It is also divisible by 400. From the theorem, its a leap year code is 1 because it is in the month of January. For the day code, Pope Gregory XIII determined the number of codes for the day of the week as follows. So we have 0 for Sunday, 1 for Monday, 2 for Tuesday, 3 for Wednesday, 4 for Thursday, 5 for Friday, and 6 for Saturday. After identifying the codes, we can now solve for the day of the week. So let's have an example. Anna was born on July 27, 2004. Determine the day of the week using Gregorian calendar. So our formula is day of the week is equal to year code plus month code plus century code plus day number minus leap year code modulo 7. So first thing is identify the codes. So for year code, we have the formula YY plus YY over 4, and the last 2 digit that is in the given problem is 04. So we substitute it into the formula for finding the year code. We have 04 plus 04 over 04, and 04 over 04 is equal to 1, and 04 plus 1 is equal to 5. And we have our year code, which is equal to 5. So next is the month code. So the month on the given problem is July, and it has the corresponding code, which is 6. Next is the century code. So the year is in 2004, and 2004 is included in the century, which is 2000, and it has the corresponding number, which is 6. Next is the day number. The day number is simply the date of the given date, which is 27. So next is the leap year code. So our leap year code is equal to 0 since our month is not in January or February. So after identifying the codes, we can now find the day code. Now we have the formula day code is equal to year code plus month code plus century code plus day number minus leap year code modulo 7, and we will substitute the codes that we get a while ago. So we will have 5 plus 6 plus 6 plus 27 minus 0 modulo 7. So the sum of all the numbers is 44 modulo 7. So here, what we will get is only the remainder. So 44 modulo 7 is equal to 2. Therefore, the day code is 2, which is Tuesday. So Anna was born on July 27, 2004, which is Tuesday. So, by mastering these steps and understanding the underlying principles of the Gregorian calendar, anyone can accurately determine the day of the week for any date, enhancing their appreciation and timekeeping and the structure of our calendar system.